Hey guys, today we're looking at additive and multiplicative patterns in tables and in graphs. And so additive patterns, even though it just has the word add in it, what it means is that we're either adding or taking away different values. So we want to look at what the pattern is from our input to our output. And I know that X is, X is my input and Y is my output. So when I'm looking, I see that I go from X being 2 to Y is 4. And then from X being 3 to Y being 5. So I'm seeing that every time I'm adding 2. So then my rule would be that X plus 2 is equal to Y. I could also write that and say that Y is equal to X plus 2. So when we look at our second one, now I see I'm going from 2 down to 1, and from 4 down to 3, 6 down to 5, and 8 down to 7. So this time I'm not adding, I'm actually taking 1 away every time. So my rule would be X minus 1 would equal the Y. So my input minus 1 gives me that output value. I could also write that as Y is equal to X minus 1. They're the same thing, I'm simply just flipping everything over the equal sign. And so for our multiplicative patterns, again, it has the word multiply in it, but it also means divide. So now when I look at X to Y, my input to my output, my brain is already thinking, hey, 2 plus 2 is 4. But 3 plus 2 does not equal 6. So I know that this will not be an additive pattern. So now I look closer and I see that, well, if I double 2, that gives me 4. If I double 3, that gives me 6. If I double 4, that gives me 8. And 5 doubled is 10. So this is a multiplicative pattern. That means that 2 times the input is equal to the output. Again, I could also write that as Y equals 2 times X. When I look at the next table, again, if we look at that first point, it looks just like the one that we did, right? 2 minus 1 is 1. But 4 minus 1 does not give us 2. So we look a little closer. And I see I'm taking half of everything. So I can look at that either as multiplying by 1/2 or saying, hey, 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. So for our rule, we can say X divided by 2 is equal to Y. I also know that division can be represented as a fraction. So I could say X divided into 2 parts is equal to Y. They mean the same exact thing, just represented a little differently. So now we've seen additive and multiplicative patterns in tables, we want to look at them in graphs. So when I see my graph, I see some points that I can put into a table. I have the first point, which is 1, 6, 2, 7, and 4, 8. So I see 4 times 2 is 8, but that does not work for 2 times 2 to get to 7, or 1 times 2 to get to 6. So then I'm looking at additive, and I see 1 plus 5 is 6, 2 plus 5 is 7, and 4 plus 5. Oop, that's where we messed up. That is not the 0.48, it's actually the 0.38. which makes more sense, and 3 plus 5 is 8. And guys, that's a great way to fact check yourself. So if you're doing something and you don't feel like it looks right, take a second look, because it's possible that we make mistakes. So this pattern, we're adding every time. We're taking x, we're adding 5 to get to our output. And notice I can still continue that point down backwards or forwards. I can continue the pattern. For multiplicative patterns, again, I can take those coordinates and pull them off into a table. My first point is 1, 2, then 2, 4, 3, 6, 4, 8, and 5, 10. And so quickly I'm seeing that my x's are just doubling. They're multiplying by 2 to get to my output. So I know that x times 2 is equal to y. Another way to word that would be 2 times x is equal to y. And the fun thing about multiplicative patterns is that they are always going to go through the origin. So notice that the first graph right here did not pass through the origin, and it was additive. But our second graph did pass through the origin, and it was multiplicative. All right, thanks.